Good evening, all. Welcome to Anis Defense Career Institute online session regarding measures of dispersion. Measures of dispersion is an important topic in our 11th standard. So, what is dispersion? In your previous classes, you have studied mean, mode, median. Mean means average of a data. For example, for a normal case, we will add all the information together. Then we will divide by the number of the information or number of observation. Sum of all observation divided by number of observation. That is represented as mean. Similarly, mode, which value is coming maximum number of times or with maximum frequency, that will be considered as mode. Median, we will arrange the data in ascending or descending order. Then we will take the middle value. So these are some analysis of our data, mean, mode, median. So we will not get a clear-cut idea about this mean, clear-cut idea about the data if we are considering mean, mode, and median. That is why we are going to a new terminology, that is dispersion. Dispersion actually, the variation from a central value, that is actually known as dispersion. If we have a standard value or if we have a central value, how the value is deviating from the mean value, that is actually represented as dispersion. An average does not tell the full story. It is hardly fully representative of a mass unless we know the manner in which the individual items scatter around it. A further description of the series is necessary if we are to go how representative the average is. That means mean, mode, median, we will not get exact information about a data. For example, this is a data score of 3 batsmen X, Y, Z. Somebody scoring 90, 17, 104, 33, 6. And the batsman Y is scoring 40, 60, 55, 50, 45. Batman Z 112, 8, 96, 29, 5. So if you calculate the sum of this data, the sum of all observation for X, Y, Z all are equal to 250. So number of observation 1, 2, 3, 4, 5. So 250 by 5, you are getting the value, mean value 50. So there are 3 batsmen X, Y, Z, but mean value is same for all the 3. But if you silently observe the consistency, if for example, in case of X, he is scoring a mark of scoring a run of 6, and at the same time he is scoring a run of 104 also. Similarly for Z, maximum score is 112 and minimum score is 5. So the reliability of the batsman X and Z is not good. But if you see the batsman Y, even though he is not scoring 100 runs, but he is consistent. He for 5 matches, he is scoring 40, 60, 55, 50, 45. Because he is a reliable person. Because he is consistent in his performance. So consistency is more for the batsman Y. Even though the mean of X, Y, Z, 3 of them are equal, we can get a consistent batsman if you take the Y. So mean is not providing or talking about the consistency. So therefore we are going for the terminology dispersion. From the mean value, what is actually the variation? That is represented as dispersion or measure of dispersion. From a mean value, our data is how the data is deviated from its mean value. That is represented as dispersion. So related to dispersion, there are three terminology we are using. First one is range, second one is variance, and third one is standard deviation. So what is actually meaning of range? We have some data, collection of data. We will observe the maximum value and we will observe the minimum value. Then we will take the difference between the largest value and the smallest value. That is known as range. That is actually equal to range of a observations. But range is also not bothered about the in between observations. It is only bothered about the highest value and the lowest value. So that is a main drawback of the range. So we are going to variance standard deviation. Why? Range is considered only about the maximum value and the minimum value. It is not bothered about the in between observation. So we need a parameter which will consider all the observation. Such an observation is variance and standard deviation. For example, here that is an example of range. Here 10 students are there and the weight of the students are given. So maximum weight is 73, and the minimum weight is 36. So range of the data is considered as 73 minus 36, that is 37. The highest value minus lowest value. Another example, here salary of different employees is given in a company. Some are getting 30 to 50,000, some are getting 50 to 70,000, 70 to 90,000. So number of people who are getting, the range is given here. Here we will consider the range of value. The maximum salary is 150 and the minimum salary is 30. So the highest salary minus the lowest salary, that can be considered as the range. So here these are the two examples of range. But the problem is range is not bothered about the in between observation. It only considering the highest value and the lowest value. So we are going for the two terminology, two parameters, variance and standard deviation. It will consider almost all observations equally. That is known as variance and standard deviation. Variance is represented as sigma square. Variance is represented as sigma square, and the square root or under root of variance is represented as standard deviation. The normal formula of variance is sigma score is equal to summation of I equal to 1 to n xi minus x bar the whole square divided by n. That is the formula for variance. If we expand that formula, you will be able to simplify that equation finally into this one. Both are same. If you apply this one or if you apply this one, you will get the same answer, because this is actually the simplification of this one. Finally we are getting the simplified form of the original formula. So variance can be calculated and standard deviation can be taken from the by taking the square root of the variance. So variance for raw data is given here. That is the same formula applied here. And finally, by simplifying the equation, you will be getting this formula, where x bar represents the mean of the n observation. X bar is equal to summation of I equal to 1 to n xi by number of observation. If it is an ungrouped frequency distribution, we can use this formula. That is also we are getting from the base formula only. By simplifying that, you will be able to get this value, where x bar represents the mean value and n represents the cumulative frequency or sum of all individual frequencies. That is for ungrouped frequency distribution. For grouped frequency distribution, The observation x1, x2, x3, etc. represented as the average of the each class. Average of the each class. Here also we can use the same formula. So variance or standard deviation of raw data, variance or standard deviation of ungrouped data, and variance and standard deviation of grouped frequency distribution. Then here the variance standard deviation we can consider with respect to the change of origin and scale. Change of origin means instead of taking the value xi, each observation will be changed little bit. That is, new value is d equal to xi minus a. What is a? A is the class mark of the middle class interval. If the number of classes is odd, or if the number of classes is even, then there will be two middle class intervals, and a can be considered as the class mark with higher frequency. So if you use change of origin, the variance and standard deviation will not change. For example, the standard deviation of x1, x2, x3, etc., xn is sigma x. And we are making a change of origin such that x1 minus a, x2 minus a, x3 minus a. For each value, we are making that deviation. So what is the value of the new variance or standard deviation? That is same as that of the old one. The meaning is the change of origin will not affect the variance and standard deviation. Means all observation should be made a little change. Then you have to calculate the variance and standard deviation of the newly received n data. Then here we are changing the change of scale. Change of scale is represented as u equal to x minus a by h, where a is the class mark of the middle class interval. Here h is the width of the class. Change of scale means we are changing the scale. We are changing the scale. If we change the scale, then definitely it will affect the standard deviation and variance. How it is affected? For example, if sigma x is the standard deviation of the values x1, x2, etc., xn, then standard deviation of x1 minus a by h, x2 minus a by h, x3 minus a by h, etc., xn minus a by h will be sigma u. Then what is the relation between sigma x and sigma u? Sigma u can be considered as 1 by h times sigma x. Sigma u is equal to 1 by h times sigma x. Or you can say that sigma x is equal to h into sigma u. That is variance. So this is the way standard deviation. So standard deviation is sigma. So sigma is obtained by taking the square root of the variance. For example, here one problem is given here. Compute variance and standard deviation of the following data observation. Either we have so many observation and xi minus x bar is taken here, xi minus x bar the whole square. So by using the normal or standard formula, variance is equal to 1 by n into sigma xi minus x bar the whole square. Xi minus x bar the whole square is actually 252. So 252 divided by n. How n is 1, 2, 3, 4, 5, 6, 7. 7 observations are there. and xi minus x by x bar the whole square, the summation is getting 252. So 252 by 7 is actually 36. This formula we can use. This formula we can use. Or this also you can use, because we already told the same formula can be represented in two forms. This is actually the base formula. If we simplify that, you can get the final formula like this also. If you apply this formula or this formula, you will be getting the same answer. So here we use this initial formula. In the next question, we will use the simplified one. Here you can see the simplified one. So given below are the marks of 25, marks out of 25 of 5 students. So 10 mark, 13, 17, 20, 23. And xi square is just a square of the observation. So what is the final simplified formula? Variance is equal to sigma square is equal to summation of I equal to 1 to n xi square minus x bar the whole square by n. So just to put this value 1487 divided by number of observation is 5. So 1487 by 5 minus x bar the whole square. X bar is actually summation of I equal to 1 to n xi by n. So just to substitute, so you'll be getting the answer 4.67. So here we used the simplified formula. Here used the initial formula. In both ways we can do. I want to tell you that this is actual formula. If you are simplifying, you will get this formula. Both are same. Both are same. In this problem, they used xi minus x bar the whole square. Either they used xi square. Both formula you can use. Anyway, you will be getting the same answer. Here another question. A die is rolled 30 times and the following distribution is obtained. Find the variance and standard deviation. A die is rolled. Means what are the possible outputs? It can be 1, 2, 3, 4, 5, 6. 1 occurred 2 times. 2 occurred 6 times. 3 occurred 2 times, 4, 5 times, 5, 10 times, 6, 5 times. So here you are writing all the marks, corresponding frequency and Fi value, then Fi square. This is coming under the variance and standard deviation of ungrouped frequency distribution. Ungrouped frequency distribution. Just use this formula. Variance is equal to sigma square. Sigma square equal to summation of Fi xi square divided by n minus x bar square. Fi xi square is actually 554. So you are putting 554 divided by sum of frequency is 30. Therefore, n is equal to 30. So 554 by 30 minus mean square. So here mean is Fi xi by n. So Fi xi is 120 and n is 30. So 120 by 30 is 4. So you will be getting answer 2.47. If you take the under root of that, you will get the standard deviation also. So sigma is the standard deviation obtained by taking the square root of the variance. So this is initially we discussed about the raw data. In this problem, we are discussing about the ungrouped frequency distribution. Here we are dealing with the okay. Then this is a problem with regard to the calculate the standard deviation and variance. Here we are using a change of scale method. So u equal to x minus 30 by h. 30 means we are taking the middle value 5, 20, 25, 45, 40, 35. So we are taking the 30 value. So x minus 30 by 5. So u can be represented as x minus 30 by 5. So if you put each value here, 15 minus 30 by 5, so minus 15 by 5 minus 3. So based on that calculation, you will be getting all the values of u. Fi is also there. Then fi, ui, fu square. Then here we are having too many observation u1, u2, u3 like that. Then what is the variance and standard deviation? Here we are using in terms of x. Sigma x square equal to summation of xi square by n. Similarly, instead of x, here you have to use u. That is only difference. So instead of x1, x2, x3, x1 observation, we have to take u1, u2, u3, etc. up to un observations. So this is, you are getting fi u square, this is 372 by 100 minus mean of all the data 0.04 square. So you are getting the value 3.7184. That is related to the change of scale. So change of scale means sigma u. Original value is sigma x. So this is the standard deviation after change of scale. This is the standard deviation of the original data. So what is the relation? Sigma x is equal to h times sigma u. Here h is width. If that width is not specified, then width can be considered as the difference between the consecutive observation. Here 20 minus 50 or 25 minus 20, 30 minus 25, all are getting 5. So therefore the value of h is taken as h equal to 5. So you are getting sigma x. This is another case. Here frequency distribution is used. If frequency distribution is not given, then width is the difference between the consecutive observation. If the grouped frequency distribution is given, then width can be directly calculated. For example, class interval 40 to 55. What is h? H is equal to 10. H equal to 10. So what is xi? The middle value of 45 and 55. So 45 plus 55, you will be getting 100. 100 by 2, 50. 55 plus 65, you will be getting 120. 120 by 2, 60. So middle value is xi. Then fi is given. Ui can be calculated by using x minus 90 by 10. How you got the 90? You have to get the middle value. 1, 2, 3, 4, 5, 6, 7, 8. If odd number, middle value can be calculated exactly. Even numbers of observations are there. Take the middle two. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. Fourth one. 1, 2, 3, 4. Fourth one. So you are getting 2. You are getting 2. From this, you have to take the value with the lower frequency. So you are getting 13. The lower frequency, this can be considered as 90. So middle class, the value of A is considered as 90. So by putting A equal to 90 and class width is actually 10, because 45 to 55, the class width is actually 10 only. So by using that, corresponding value of ui can be calculated, fi ui can be calculated, fi ui score can be calculated. So by using our standard formula, sigma u square is equal to summation of fi ui square divided by n minus u bar square. So just to substitute, 450 divided by n is the sum of the frequency. So 450 by 100 minus mean of observation, that is u bar square, you will be getting 2.25. Then, so this is with the case of change of scale. So if without change of scale, you have to calculate. So sigma x you have to calculate. So variance is equal to h square into, that means sigma x is equal to h into sigma u, or sigma x square is equal to h square into sigma u square. Sigma q square is variance of x into equal to h square into variance of u. That formula is used here. So variance he got 2.25, h square is 10 square, so you'll be getting 225. So if you use change of origin, the variance and standard deviation will not change. But if you use change of scale, it will be definitely affected in the final value. So how it is affected? Sigma x square is equal to h square into sigma u square. That means sigma x is standard deviation of observation x1, x2, etc. up to xn, and sigma u is the standard deviation of observation u1, u2, u3, etc. up to un, and sigma x square is represented as the variance. The next problem similar to that same case only. Here u is x minus 32.5 divided by 5. Here 32.5. So 1, 2, 3, 4, 5, 6. So these are the middle values. So here this 32.5 is considered as the value of A. So x minus 32.5 divided by width of the class, that is h is equal to 5. Just apply that and calculate all the values of ui. So you are getting FIUI square. Just substitute in this formula. So you'll be getting the variance is equal to 2.7824. Variance of x is equal to h square into variance of u. So just substitute this value, and h value is 5. So 5 square, h square into 2.7894. So you'll be getting 69.56. That is actually the variance. Standard deviation means the square root of variance. So what we have discussed here up to this point, mean, mode, median, that cannot be used for analyzing the all data. Instead of that, we need some parameter which represent almost all observation. That is why we are going for range, variance, and standard deviation. Range means the difference between highest value and lowest value. So range also we cannot depend, because it does not consider the in between observation. It talks about only the maximum value and minimum value. Therefore, we are going for the standard deviation and variance, because standard deviation and variance, it taking consideration of almost all observations. So this result is more accurate, because that the value given by standard deviation variance is by considering almost all observation. Then we discussed the variance and standard deviation will not be affected by change of origin, but it will get affected by change of scale. So these are the content we discussed up to here. Then here you can see sigma 1 is the standard deviation of n1 observation, and mean is x1 bar. Sigma 2 is the standard deviation of n2 observation, whose mean is x2 bar. So what will be the combined mean of these two data? x1 bar is the mean of n1 observation, x2 bar is the mean of n2 observation, and the corresponding standard deviation is sigma 1 and sigma 2. So the combined mean can be represented by this equation. Xc bar equal to n1 x1 bar plus n2 x2 bar by n1 plus n2. So that is the formula for combined mean. Then what is the formula for combined standard deviation? That is represented as sigma c equal to under root of n1 sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square divided by n1 plus n2. What is d1 and d2? d1 is the difference between the first mean and the combined mean. Similarly, d2 is the difference between the first mean of the n2 observation and the combined mean. Just to calculate this value and substitute, you will be able to calculate the combined standard deviation of both the data. Here, the means of two sample sizes 10 and 20 are means n1 equal to 10, n2 equal to 20. Mean is given as 24 and 45. And standard deviation is given as 6 and 11. So you have to calculate the combined mean and combined standard deviation of the complete data. Because 10 items, mean is 24, standard deviation 6. 20 item, mean is 45 and standard deviation is 11. So if you combine both, you will be getting 20 plus 10, 30 observations. So 20 plus 30. So for the 30 observation, what is the mean? What is the formula? Xc bar equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. n1 is 10, x1 bar is 24, n2 is 20, x2 bar is 45. n1 plus n2 is 10 plus 20. So you'll be getting 38. So combined standard deviation can be calculated by this formula. Sigma c equal to root of n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square divided by n1 plus n2. What is d1? x1 bar minus xc bar. xc bar is actually 38. x1 bar is 24. So 24 minus 30, 38. It will be minus 14. x2 bar is 45. 45 minus 38, you will be getting minus 7. This is plus 7. 45 minus 38 plus 7. So just to put that values in this equation. n1 is 10, sigma 1 is 6. Sigma 1 is given as 6. So sigma 1 square matlab 6 square. d1 square is actually minus 14 square. n2 is 20. Sigma 2 is 11, so 11 square. d2 is 7, so 7 square. Just to substitute, you will be getting the value. So n1 data with x1 mean and sigma 1 standard deviation. n2 data x2 mean and sigma 2 is the standard deviation. So combined mean will be xc is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. And combined standard deviation, the formula is this one. Just to substitute the formula, you will be getting the answer. Only calculation is there. Another example. The first group has 100 items with the mean 45 and variance 49. n1 equal to 100, x1 bar is equal to 45, and standard variance is given. Variance means square of the standard deviation. So sigma 1 square is given. Combined group has 250 items. Combined mean is 51. And combined standard deviation sigma c square is equal to 130. So you have to calculate the value of n2 x2 bar. So n1 plus n2 is given as 250. So N1 is already 100. So N2 will be 150. Xc bar, the combined mean can be represented as N1 X1 bar plus N2 X2 bar divided by N1 plus N2. So combined mean is given as 51 and N1 is already 100, N2 is 150. So just to put the values here, so you will be able to get the value of X2 bar, that is equal to 55. The combined deviation is actually this formula, sigma c equal to root of. So if we square on both sides, sigma c square is equal to N1 into sigma 1 square plus d1, this formula. In this formula, you can put the corresponding value. D1 is x1 bar minus xc bar. X1 bar is actually 45 minus 51. So you'll be getting minus 6. D2 equal x2 bar minus xc. That is 55 minus 51. So that is D2 is equal to 4. So just to substitute in this equation, so you'll be getting an equation with the sigma 2 square. Just to rearrange, you will be getting the sigma 2 square is equal to 144, sigma is equal to 12. You cannot take negative. You can take only positive value. Therefore, sigma 2 will become 12. The standard deviation of the second group is 12. And the so standard deviation x2 bar you got it as 55, n2 you got it as 150, and sigma 2 you got it as 12. So these are the solution of this particular case. So far we told mean is not considering all the observation, median is not considering all the observation, and mode is also not bothered about all the observation. So we have to take a parameter which will give you a value considering all the observation. That is why we are going to dispersion, measure of dispersion. So in dispersion, we are dealing with the range, standard deviation, and variance. Because dispersion means variation of the value from the mean value. So here range, even though we are considering range is actually considering only the largest and smallest value. So we cannot rely on range also because it is not considering the in between values. So we are going for standard deviation variance. So standard deviation and variance considering almost all observation. So this is a this standard deviation and variance is the best parameter to analyze our data. But another problem with the standard deviation and standard deviation variance is if the observations are of identical units, two different types of observation cannot be compared with the help of standard deviation or variance. So because standard deviation depends upon the unit of measurement, therefore it cannot be used to compare two or more series expressed in different units. What is the drawback of standard deviation and variance? If you calculate the standard deviation, you are considering only observation with identical units. In the case of standard deviation and variance, we are dealing with the observation of same units. But if you want to analyze two different set of observation with two different unit of measurement, what is the possibility? So in that case, we can use coefficient of variation. What is coefficient of variation? Coefficient of variation is represented as coefficient of variation CV is equal to 100 into sigma by x bar. That is known as coefficient of variation. By coefficient of variation, we can compare two different distributions. If you have a large value of CV, we can say that it is heterogeneous, and if value of coefficient of variation is smaller, then we can say that it is homogeneous or compact. So homogeneous data or the distribution with smaller coefficient of variance, we can say that it is more consistent in nature, more consistent in nature. So basic formula of coefficient of variation is coefficient of variation CV equal to 100 into sigma by x bar. Here you can see the arithmetic mean of runs scored by three batsmen Varad, Viraj and Akhilesh in the same series are 50, 52, 21 respectively. The standard deviation of their runs are 11, 16, 5 respectively. Who is the most consistent person here? Whether it is Varad, Viraj or Akhilesh. What we will do? We will calculate the coefficient of variance. What is coefficient of variance? 100 into sigma 1 by x1. So 100 into, so first person 11. So 11 divided by mean 50. 100 into 11 by 50. You are getting 22. For the second person 100 into 16 by 52. 30.76. Third person 100 into 5 divided by 21. You are getting 23.82. So for the first person 22 is the coefficient of variance. Second person 30.76 and third person 23.81. So CV is less here. The value of CV is less here. So the data with the lower value of CV will be more consistent in nature. Distribution with the small value of coefficient of variance is more compact or homogeneous, or we can say that it is more consistent in nature. So here, out of three persons, Varad is the most consistent person. So if you observe the data based on the consistency, Varad is the way coefficient of variance of Varad is actually smaller. So we can say that he is more a consistent player. He is more consistent. If you observe, if you want to get a better score, then highest, if you take the player based on the highest expected score, then you have to consider Viraj because his mean value is greater. Here you can see mean value is highest for Viraj. Mean value is highest for Viraj. So who will possibility of the person who score large value, we can consider it as Viraj. But the person who is more consistent in scoring, that is Varad, because the coefficient of Varad is least, the observation with the least coefficient of variance is said to be more consistent. So in base of consistency, you have to select Varad. If you want to get maximum possible score, you have to go along with Viraj. So that is the idea of coefficient of variance. Here also, the following values are calculated in respect of prices of two companies X and Y. Which company is more stable? Because X and Y, two companies, their product may be different. Their working atmosphere may be different. Everything is different. But we have to compare X and Y, two companies. For example, X is a washing machine company and Y is a some textile industry. So if a person want to invest some money in company, So which company he should prefer? Which one gives consistency? That company he should prefer. So mean of the y is 50 and variance is 7. Mean of x is 50 and variance is 7, and mean of company Y is 105 and variance is 4. To take the value of coefficient of variance, so 100 into sigma x by x bar. So variance is given. That means standard deviation is actually the square root of variance. So sigma x square is 7. So standard deviation will become root 7, that is 2.64. In second case, sigma y score is given as 4. So the standard deviation become 2. So 100 into 2.64 by 50, 5.28. And similarly for coefficient, for the company Y, coefficient of variance is 100 into sigma y by y bar. So 100 into 2 by 105. So 1.90 and 5.28 are the coefficient of variance of two companies. So the company with low value of coefficient of variance, we can say that more consistent in performance. So if you want to put share, put it on company Y. So these are the topics we discussed. I will just give a brief once again. Mean, mode, and median are the some information to observe the some collected data, but it will not give accurate value because it is not bothered about all the observations. So we have to get no parameter that will take consider almost all observation. That is why we are going for dispersion concept. Dispersion is actually the variation of the observation from the mean value, that is considered as dispersion. Dispersion is divided into three types of parameters. One is range, another is standard deviation and variance. But range is also discussing about the highest and lowest value. It is not bothered about the in-between value. So range is also not that much reliable. So we are going for variance and standard deviation. Variance and standard deviation considering almost all observation taken into account while calculating the variance and standard deviation. So variance and standard deviation are the best parameters to analyze complete data. Then what is the problem with variance and standard deviation? Because variance is calculated for observation with the identical units. We cannot calculate the variance and standard deviation for different observation with the different units. That is a limitation. So that is why we are going for another parameter that is known as coefficient of variance. In the last example, we discussed about the two companies, X and Y. One is a textile industry, another one is a washing machine company. The entire product and entire procedure, everything is different for textile industry and washing machine company. So for if suppose I want to give some money as a share to any one of the company, so that after 1 or 2 years I will get more benefit. So I have to consider a company with consistent performance. So in the unit, if you observe the performance of these two companies, you cannot use standard deviation variance concept here. Here you have to use coefficient of variance. If you use coefficient of variance, you will be able to say the consistency of the two companies. So company with the coefficient of variance, if the value of the coefficient of variance is less, then we can say that the company is more consistent. So coefficient of variance is used where the observations are of two different entity or two different units. In such a case, if you want to compare the two different set of data, the best is to use coefficient of variance. So these are the topics we have to deal in case of measures of dispersion. So thank you for attending this session. If you have any queries, you can contact, and thank you for attending this session. Thank you.